Entrepreneurs are a little different, but since 1979, I've created my own job. And so you have to keep several irons in the fire. And this is a new concept that we have been exploring at Exploration Partners. We've been in business for about 4 years, mostly in shuttle activity. We're going to talk about a two-cell, higher efficiency, basic concept, which we need to move toward a business as quick as we can. And we're a little bit frustrated by the fact that we've been looking at space solar power for 40 years. And the original Peter Glaser design, I can remember back to the Lincoln conference where we were really excited about space solar power, and I put in a paper and quickly forgot about it. And I had a friend of mine call me and say he read it, which doesn't mean much, but other than I'm that old. So we're going to split the...
This one, this.
I got it.
Point it here.
Projector.
Oh. Okay, let me talk a little about the introduction.
Okay.
Well, maybe not. All right. Forget the introduction. Basic concept, we're using two different PV cells. We're bringing in solar radiation. We're looking at ground systems initially to create some money, and that we then use a hot filter, a hot mirror, and a cold mirror to split that light frequency to give the cells down there in blue the kind of frequency that they are most appreciate and can create more than normal power from. We also then add massive solar concentration, and it looks something like this with the reflectors visible. And so as entrepreneurs, we think about the future market, how we sell this thing in the real world of roofs in New Mexico, for example, or elsewhere in America. And we have to then be lower in cost initially and higher in efficiency than the low-cost leader, which appears to be Harbor Freight up here in the top. And they get to about $3 a watt. So this would be the beginnings of a concept that we're starting to explore. And I won't speak any more about the roof tops units, but more about the space unit because basically we're at a space conference. So the energy comes in from the side, and it bounces off and heats up this small set of PV cells, and then it generates enough electricity that we have active cooling that cools that, and then a large transmitter for transmitting to the ground customer. And we have other things that are always inherent on satellites that include propellant tanks and all that. We're looking at several designs. This is the same design you've just seen, but in kind of 3-dimension. And we're looking at the possibility of the launch vehicle being part of our radiator system. Because when you get into massive solar concentration like we're envisioning, you end up with a lot of heat. And we need ways of getting rid of that heat. So we're looking to think of a Delta II launch with a demonstrator satellite that would look something like this. Certainly not a final design, but we do think that the radiator tanks idea might be of benefit for us. Another 4-reflector system, which would use inflatable reflectors that would focus on a red X kind of a receiving device that looks about like that. with solar cells on these surfaces up and down, and we would still use that splitting of the sunlight frequency to get to a system that is a bit more complicated when you, yeah. So if you'll go down to the lower left, your lower left corner there, we use a special PV cell right here behind this mirror, and another cell along here, and they then add the mirrors that were added here, and then over on the third corner here, we've got the sunlight coming in, the frequency split, and so each cell gets the kind of sunlight that it does best. And then, as you might imagine, we'll be limited by active cooling. So we think that the cooling could be as sophisticated as liquid metal, but when we're looking at massive solar concentration, we would expect to go as high as we can go and still actively cool it. So cooling may be the limiting factor for us. This is a rainbow concept, and most of you are probably familiar with it. I won't spend a lot of time, but this is a Fresnel lens, sunlight coming in, and there's 6 solar cells on the side that are described here, and they get then an increase in created or the electrical output. So we're always interested in the market and what market might be captured by such a device. And as an entrepreneur, you can't pour billions of dollars into something without a market that would pay back the investors. So we think that the easiest market for us to approach would be the 20 degrees north and south of the equator. And in those regions, we've got underdeveloped countries, mining companies, and other people who basically burn diesel fuel for power. I've lived in some of those areas, and they don't have the sophistication of giant power grids and stuff like we have in a developed country. So they're probably susceptible to $6 and $8 a gallon diesel, and it could be double or triple that in the coming decades. We also make some other changes so that we can actually get a system in orbit as fast as we can. So we're really saying that these beginning demo satellite would actually be down to just under the Van Allen belt, which probably starts about 900 kilometers up. And so we would have the ability to raise these satellites once they come down. We also then would be passing over our customer's rectenna, and we hope electronically steering our transmitters so that we can feed them power for 5, 10, 15 minutes while we're over them. And we would do that 12 to 15 times a day. So it's a little different than everybody envisions with the units that geostationary. We believe in order to get us started, we have to attack some of the barriers that we currently see within the space solar power arena. We have reduced the number of vehicles it takes to get to the final use location by one trip. Going to GEO, of course, is usually thought of as being assembled in low Earth orbit and then transmitted or ion propelled up to geostationary. So we've eliminated that geostationary trip. We also eliminated the ability to spend billions and never get the first kilowatt out until you've actually spent that money and put it in orbit. We think that we can put together a demo that might deliver electricity to equatorial customers as a demo and prove out the concept and get us into a financing scenario that, quite frankly, uses the same financing scenarios and mechanisms that are used in the communications industry today. So we're really in the business of leasing satellites, not necessarily producing power. Our power customer on the ground would be the retail electrical seller or that we have in all developed countries. The people that you pay your power bill to would be the guy would be receiving our power. So it's a little bit different than what we normally think of in a developed country. And we expect to make those people wealthy by joining us early on. Everybody believes that we need to raise the solar cell efficiency before we can get into big-time operations in space solar power. We believe that solar concentration, maybe even massive solar concentration, can take the kind of cells that we can get out of the lab today and with a little bit of innovation, make them the beginning of a different industry. Large systems in space solar power also require large antennas on the ground and fairly large hardware in orbit. We've reduced most of that mass to both on the ground and in orbit by changing the method and changing the way we do things. Also, it has an effect on many other things. Big antennas and all of the power coming down to one location also requires a power grid. What we've done here is reduce some of that. Now, about a year and a half ago, we did a study that looked at the manned shuttle-arrived vehicle, which of course now is thought to be dead and buried, although there are some indications that's not true. And so we did a little bit of work on what we could do with the space shuttle if we modernized it a bit. We used the old hardware, but used it in a new way. We also have been working with some of the shuttle-arrived people and advocates that are still in the government. And we came up with this concept for a larger space solar power unit. And here's the long kind of mechanisms. They're in inflatable structures that really put together and come up with something like this. The inflatable structure you saw is really this, this, and this, all the way around. We leave the tank in there because we expect to use that as a radiator. And the vehicle payload came up in this particular vehicle. If we become sophisticated, we might take the engines back to Earth, but for right now, we don't worry about it. So this is the hemisphere, the half a circle here that heats up these solar cells. Of course, you need active cooling, but this becomes a fairly large facility in orbit. It would, again, be under the Van Allen belt, and because it's so big and bulky, it would probably re-enter without additional reboost propellant in about 11 years. The external tank unaided has been looked at about going to orbit, and at 300 nautical miles, it will re-enter in about 11 years. So this is big and bulky, but what happens is that it's got some natural issues as well. If you've got the sun coming in from the right, you've got some of these different areas excited by the sunlight. The Earth, of course, here is in the center, but you also have the external tank, which, because it has some foam on it, will go to bright metal in about a year to 18 months in orbit just by spalling off. So that would become our radiator. There's actually two tanks of 19,000 cubic feet here and another 54,000 cubic feet of internal volume that we would use. And we've been thinking about what kind of radiator that might make for us. But also, it's fair to say that you'd need to have the radiation to the blackness of space. And this whole long body, which is about 200 feet long in orbit, would rotate 360 degrees on every orbit. And it would be going around the Earth about 12 to 15 times a day. So we're still radiating down to to willing customers here and here and here and here. And we don't have any basic energy storage here, but because we pass over customers so often in the day, we expect their facility on the ground would have new flywheels or whatever it would take for storage of the power. So we've changed the thinking a little, and in hopes of getting into a business as quick as possible, certainly quicker than 40 years. And so I began to look at what the power system in a developed country looks like. And it's kind of like this, with a generating station here, a step-up transformer, big transmission line, step-down transformer, and then a set of 3 customers here. So our first customer would be a ground solar, which I haven't said much about, but that customer could become a rooftop kind of customer. And then we ask ourselves, where do we plug into that existing system in a well-developed country without creating a lot of competition and a lot of people who are angry? Because we're really approaching everything from the coal mines to the generating station and the step up and transmission line step down. We think we could enter here like space solar power people do now, and all of that would be used by the large geostationary power plants. But we would prefer to enter here and serve these 3 customers with a smaller rectenna because we're closer to Earth, and we're a new green system, and basically the coal mine all the way up to the transformer in here somewhere are industries that are no longer required for our system. So it has some impact economically, and that's kind of what we look for as entrepreneurs. So the future, if we're able to get this kind of innovation into use in orbit, will eventually drive our species off the planet into other adventures around the solar system. But we're basically saying go back to the sun and quit using the renewable resources that have been stored on our planet, which originally came from the sun as well. And then we think America as an innovation leader needs to be that nation that does that, use that innovation to create a new system. And we think that's part of the payback that taxpayers get for supporting the space program for 60 years. So that's it. Thank you. Entrepreneurs are a little different. But since 1979, I've created my own job. And so you have to keep several irons in the fire. And this is a new concept that we have been exploring at Exploration Partners. We've been in business for about 4 years, mostly in shuttle activity. We're going to talk about a 2-cell, higher efficiency, basic concept, which we need to move toward a business as quick as we can, or in blue, the kind of frequency that they are most appreciate and can create more than normal power from. We also then add massive solar concentration, and it looks something like this with the reflectors visible. And so as entrepreneurs, we think about the future market, how we sell this thing in the real world of roofs in New Mexico, for example, or elsewhere in America. And we have to then be lower in cost initially. And we're a little bit frustrated by the fact that we've been looking at space solar power for 40 years. And the original Peter Glaser design, I can remember back to the Lincoln conference where we were really excited about space solar power, and I put in a paper and quickly forgot about it. And I had a friend of mine call me and say he read it, which doesn't mean much, but other than I'm that old. So we're going to split the,
This one, this.
I got it.
Point it here.
Projector.
Oh. Okay, let me talk a little about the introduction.
Okay.
Well, maybe not. All right. Forget the introduction. Basic concept, we're using two different PV cells. We're bringing in solar radiation. We're looking at ground systems initially to create some money, and that we then use a hot filter, a hot mirror, and a cold mirror to split that light frequency to give the cells down there, and higher in efficiency than the low-cost leader, which appears to be Harbor Freight up here in the top, and they get to about $3 a watt. So this would be the beginnings of a concept that we're starting to explore, and I won't speak any more about the roof tops units, but more about the space unit because basically we're at a space conference. So the energy comes in from the side, and heats.